All right. We're going to get started soon. We're just waiting for other people to trickle in. So we're going to have our next session, which I'm very excited about. So we started in the first session talking very kind of large-scale climate patterns, atmospheric patterns. And now we're going to talk, the session 2 is going to be on social vulnerabilities to heat. And I think it's clear by now from the panel and from our own understanding of recent events that heat extremes are not experienced equally. There's a lot of inequity in how they're distributed, and so we're going to hear more about that, and we're going to hear more about more local scales in this session. And so our first speaker is Dr. Jola Ajibade from Emory University, talking about surviving the heat. Stories of resilience and vulnerability from Portland's cascading consecutive disasters, which we also heard about.
Yeah. Thank you, everyone, for being here and coming back after lunch. So today, my talk, which I've titled Surviving the Heat, is essentially a metaphor for multiple disasters that we experienced in the Portland area in 2020 and 2021. And the connections between cascading and consecutive disasters, I'll talk about that soon. Just in case you run out of, you have to leave, I'll just give my conclusion first, and then it will be over. So the key message here, and I will show you throughout the talk, is that social vulnerability in our work did show that it was a clear predictor for exposure to cascading disasters and for impact severity, which I will show. But also, people who were exposed to one disaster were often exposed to another disaster, especially within the same tract area, which I will talk about. And we also found that heat wave deaths, which a lot of people died actually overnight, heat wave death was correlated more with land surface temperature and affected a lot of elderly people and low-income groups. So that's the message. And moving forward, I want to thank all of my collaborators. This is a work of a whole village. It's not just my work, so I'm really very thankful for everyone who've worked on this project. I will skip this slide in part because we've talked a lot about the global dimensions of heat, and I think we don't want to hammer too much on it because you guys already know it, so it will save us time. But it's happening everywhere. It's not just in America. We're experiencing it all over the world. And for some areas, it's not just the heat. It's multiple interacting disasters that is happening. And so even how you define cascading disasters can be complex. Some people talk about cascading disasters being one event having multiple sequence of other events that then affect communities, leading to compounding impact. In some instances, it could be multiple events happening at the same time, which could have cascading effects. And in the case of Portland, it's sort of both, which I will show you. And if you're interested in that work, you can check out the work from Pasquale and Alexander to see this interaction or cascading risks, however you want to define it, looking at the global dimension and the local dimension. And as I mentioned earlier, it could be seen as a domino effect as well. So it comes down to whatever definition you think is meaningful, but then it's really about this multiple impact. And this question, I think, came up earlier today, people describing the heat issue as a public health issue. Some people said it's a climate justice issue or a climate issue. And certainly some people say it's an emergency issue. Quite frankly, it's everything. I've been talking to people, do we see it as an emergency issue? Yes, it is. It's something we need to proactively respond to, but also it affects a lot of marginalized communities. It's a social justice issue. If you don't have access to air conditioning like we were talking about this morning, it's a problem. And it's a climate justice issue. It's all of these issues that we're dealing with when we're thinking about heat-related issues, and certainly when we're thinking about cascading disasters. And so in the Portland region where this work is focused on, we looked into past to so many other disasters, but we just focused on this 5-year span of time. And if you look at that 2020, I'm sorry, I'm just going to go back. Oh, I hope I can go back. Yeah, the 2020, oops, okay. If you look at the 2020 period, you would see that a lot of things happened. We were all experiencing a global pandemic. For many of you, you remember this. So we had that at the background of all of this. And then in August, between August to October, we had these wildfires, which is the Labor Day wildfires, and then the massive smog that covered the whole area. Even going far as Canada, we had those smog all everywhere. So the air pollution, the PM 2.5 resulting from that was a lot. And then shortly after that, or We also had the February snowstorm, and then we had the major heat wave. I just want to remind people also, this was the period where, in 2020, where George Floyd was killed, and there was a 1 month protest against racial injustices in this country, about the issue of racial reckoning, which seemed like people took on, and now it's somewhat disappearing. But this was the backdrop of some of the struggles that we were experiencing in the Portland region at the time. And the research we focused on was to understand what were the climatic drivers of some of those events. I won't talk about that. I think today a lot of the physical scientists already touched about so many issues around drivers of climate-related impacts and events. But I'm focusing mostly on the social side of things, right? So what makes certain people vulnerable? What's the unequal vulnerability? And also the baseline resilience. Why are some people not severely impacted while others are? And on the other side is also the issue, what can we do in terms of cascading resilience? What are the institutional opportunities and policy changes that need to happen to center equity in how we are mitigating multiple hazards? And this is the region where we worked. We looked at not just Portland City, but we looked at Washington County, 3 counties to be honest, Washington, Multnomah, and Clackamas. And then this region actually has around 1.8 million people. It's largely white, but we do have people of color, Blacks, indigenous communities, Latinx, Chinese, all different kinds of people living in the region. And another important thing is also the methods that we employed. We brought together multiple methods. We did meteorological storytelling, plus climate sequencing, which was talked about a lot today. So I'm not focusing on the red side of things, but if you focus on the blue and the green side of the methods, we did a baseline resilience analysis and social vulnerability analysis, also did a GIS mapping of these different events, spoke to households, about 30 of them, and 3 CBOs, and also did an equity analysis of the plans and policies that were in place at the time. And so bringing all of this together, what was, how did people experience all of this, these all consecutive events? The key first one was, number one, when we looked at the air pollution period, you could see, and I hope this is a little clearer to people, you could see the DEQ station. We had 5 DEQ stations we looked at, and also Purple Hair. We tried to bring them together to see what was the microgram per cubic meter of PM2.5 that people were exposed to at the time. And I really want to thank Ira, because what he mentioned was quite frankly close to what we found in our analysis when we did a calibration of these 2 different data points. And we found that on average, people were exposed to around 400 or 430 plus micrograms per cubic meter of PM2.5. And what the EPA recommends is that in a day, you shouldn't be exposed to more than 35 micrograms per cubic meter of PM2.5. So this was really high for people to be experiencing at the time. And there were areas where it was much more higher than others, as you can see. And then there was also areas where the snowstorm was severe, and there were areas where during the June 2021 events where people were exposed to 46 degrees Celsius. For those who use Celsius, for those who use Fahrenheit, it was around 116 degrees Fahrenheit, which Era mentioned as well. And so it was really horrible at the period. One of the first things we wanted to understand was, in all of these events, there were deaths that occurred with the air pollution. About 11 people died, but a lot of people lost their homes during the wildfires. And also the snowstorm destroyed houses, destroyed trees. But the event that had the most significant impact in terms of death was, or in terms of mortality, if you want, it was the heat wave. And so we looked at the heat wave mortality and correlated that with a lot of things. First, one of the things we wanted to understand is, what does it matter the kind of housing you live in when you experience an heat wave? And so we looked at where people died. Around 100 people died in Oregon. About 96 of them were in the Multnomah area, in the 3 regions that I mentioned. And people were living in different kinds of housing. There were people who died, about 36% died in multi-family units. There were people who died in single-family housing. And some people, a lot of the deaths were also recorded in homes that were older, meaning many of them may not even have air conditioning, or they may not have sufficient cooling systems of other kinds as well. So that's something we found, but that's not the most exciting part of the work, just putting that out there. We also looked at the impact of redlining to see how many people really died. For those of you who may not know redlining, it's a policy here in the US in the 1930s where they denied particularly Black communities, but also other communities of color, access to home loans, access to other sources of investment that could have improved their environment and that could improve their access to housing and better housing. So people didn't have that. And so the D area was the area that was considered hazardous, and that was the area that didn't have a lot of investment. Similarly, the C area as well. So the A area, as you see here, is where there was a lot of investment there, and some investment were also in the B areas. So when we looked in the Portland context and tried to correlate, because there are papers that have suggested the linkages between redlining and heat mortality, which is true for those analyses. But in this specific case, we found that nobody died in the A area. The B area, 13 died. The C, which is the declining area, about 20 people died, and 7 died in the D area, which is the hazardous area. So it was interesting, but this was just a simple analysis that we did. It wasn't telling us the whole story. So we felt redlining doesn't tell the full story. So we looked into what was the current state that people were experiencing. So we did a baseline resilience analysis to see what were the current factors for people. When you think about infrastructural capacities, capital, institution, environments, the economy, community capital, which is a lot of indicators to measure this. This is from the work from Kota and others, those who may be familiar with resilience indicators. She was the one that was a pioneer of that indicator. She also pioneered the social vulnerability index. So we brought together 52 different indexes to understand where do you have a variety of baseline resilience where people have high resilience, but also we try to look at what were the factors that were shaping social vulnerability in different parts. And for the social vulnerability, that tends to emphasize demographic variables, race, gender, income, occupation, things like that. So when we brought these two together, I apologize that I'm fast, but I know I have just 15 minutes, but I'm happy to answer questions. So when we brought the BRIC and the SOVI together, what we did was to understand where do you have high social vulnerability in terms of analysis based on decile, and where do you have low resilience. So when you bring these two together, we found those areas where you see the red, that intersection of SOVI and BRIC is where you have high SOVI and low BRIC. And so you can see those red spots. And these are the neighborhoods that were areas of concern in this analysis that we did. And several tracts in those neighborhoods definitely were affected. But beyond just the intersection of SOVI, we wanted to see who are the people and what tracts are in that black box where they have high SOVI, high social vulnerability, low resilience, but also experience the heat wave severely, experience the freezing precipitation, which was where we calibrated or described the snowstorm, and also got the air pollution. So we wanted to see who is in that black box and where were they. And so bringing all of this together, one of the key things we found, when you use just social vulnerability only, we're able to identify tracts that were in that black box, as you can see over there. And in this area in Clackamas, this area, the Collie area neighborhood in the Portland region. When we looked at just on the resilience side, you see a slightly larger portion where you look at low resilience and intersections with these different disasters. So we can see the tracts that were in those black boxes. And one thing we then did was to bring everything together to see where people died in terms of the heat wave. You can see the heat wave was, I'm going to go back. The heat wave was concentrated. We did this based on the data we had access to, which was given to us by Oregon health officers. And then you can see we also did this based on, the analysis was used to normalize the population. So we tried to take into consideration the population, and you can see areas where you had the highest heat wave. But one of the interesting things was we noticed that there was also a concentration of community-based organizations in those areas. This is not to say that people died because the communities were there or community-based organizations were there. It was to understand why is it that we have a lot of community-based organizations, but also we have a lot of deaths. One of the things we found in our analysis was that a lot of the organizations were not focusing on disaster. They focused on everyday issues, housing issues, general health and wellness, environmental issues. And so there were very limited people who were focusing on proactive heat or air pollution. And so those types of issues tend to be things that we leave to what is called mutual aid, where people just come together and band together to assist other people. There were no long-term investment in community-based organizations to do this kind of work. And that speaks to what Ira said in terms of we need proactive measures and investing in people to address this issue. So when we brought everything together, air pollution, deaths, land surface temperature, air temperature, freezing precipitation, and community-based organizations, we kind of wanted to see is there any relationship? And so one thing we found was that we did a Spearman rank analysis. We found that as people's social vulnerability was going up, resilience was going down, but also, I'll just talk about the two key things because my time is almost up. Social vulnerability was in fact a key predictor of where people die, the tracts where you had the heat wave, more than the heat itself. And also, most of the tracts that experienced the major disasters that experienced the heat, they also experienced the air pollution and also felt the impact of the snowstorm. So those are the key issues. And I'll move on quickly. I have just 1 minute left. When we spoke to people in terms of their experience with this, they said, we've never had to deal with this multiple effects, that it affected their underlying illnesses and exacerbated it. We spoke to a farmer. She said she lost everything. She couldn't breathe, that it was a very tough period for them. And so they talked about this lack of familiarity with dealing with multiple disasters at the time. We also spoke to people and asked if they trusted, if they had trust in government to deal with this issue moving forward. People said, hell no. I don't trust the government to respond to any of this issue. And they mentioned the fact that we would need to think also about other services that people need, Medicaid, Social Security, and they were worried about these being taken away at the federal level. So this person was talking about what's going on at the federal level and how that may affect people locally. And this person said, people will have to rely on each other, so emphasizing that issue of social capital, that they don't think the government is going to come knocking on neighbors' door and finding out who's dead, but that neighbors will have to support each other, and that's the key message from some of the neighbors we spoke to. And this is my last slide, I promise. We looked at the analysis for different policies, hazard mitigation analysis, climate action plans, and we found that, at least at the time, which was up until 2021, there was a very singular focus on single disasters rather than multiple disasters, and there wasn't a lot of policy and plans to deal with extreme heat or even wildfire-generated smoke, and also issues of equity, social vulnerability, and disaster risk reduction were siloed rather than brought together as something that needs to be focused on as a big issue. So those are my messages, and thank you for listening. Happy to take questions.
Thanks, Jola. That was really great. That's an awesome talk, and thanks for setting the stage for the rest of the talks as well. I think we have time for maybe one very quick question with a very short answer. Who wants to go?
This is about the graph that you showed about housing type and heat wave deaths. I know that there was grouping down into different types. I was wondering if there was one housing type that was overrepresented in that breakdown compared to the rest of the existing housing stock.
Well, it wasn't overrepresented. We just noticed that people in multifamily housing also, you had a lot of debt. But one thing we found in terms of the person who really died, most of them were elderly, and most of them were also living in isolation. So that was something that came out as a surprise to us. And then it was during COVID. So people were not knocking on each other's door to find out, are you safe? Is it too hot for you? Can I help you? So the COVID might have played into why people died in isolation.
Thanks, Jola. So please feel free to reach out to Jola after this for more questions. So next we have an invited talk by Lynée Turek-Hankins, and it's taking us to Miami, where we're going to learn about indoor heat and energy affordability and how they affect household risks.
All right. Hopefully this works. So, hello everyone. As she said, my name is Lynée. I actually just finished my PhD at the University of Miami, so I'll be talking about some work I did there, focused really on interactions between indoor heat and energy affordability. And I think my other speakers have done a really wonderful job setting the stage for why we care about indoor heat, especially Jola with her presentation. So instead, I'm going to start with the context I'm coming from, which is from Miami-Dade County. So Miami-Dade is the 7th largest county by population in the United States. It's the largest county by population in in Florida. And also interestingly, my background is actually in building energy physics. And so it's the only place in the continental US with its particular climate zone. So it's a very unique place. And looking at the literature, we know that there are certain things that make some people more susceptible to indoor heat than others. These have been looked at across the globe, and so we have them up here. But what I think is really interesting is that this is within the indoor heat literature. But if you take a step over to a very closely related literature, you see that these are the exact same drivers in the energy burden literature. And so here we have these two literatures that are very well understanding of the other. We know that if you don't have good access to air conditioning, that means you're more likely to be hot inside, and that's the indoor heat side. But then on the energy side, we have people saying, hey, if you can't afford your energy, it might be too hot. And so we had these people kind of talking past each other, looking at two sides of the same coin. And that's really the problem I wanted to look at, which is that at the moment, indoor heat and energy affordability are really studied in silos. So what happens if we give each of them equal weight? We equally care about the problem of indoor heat, and we equally care about the problem of people not being able to afford the energy and spending way too much money on energy. And so this work was done in collaboration with really wonderful people and with really wonderful organizations. So I had the opportunity to work with several different organizations in Miami-Dade County. Jen Gilbert, who was one of the speakers earlier, was a big collaborator with this project. And I also want to flag Catalyst Miami, which is our main local partner. They're an economic justice-focused organization, really pivotal in this work. And so the specific research questions I tackled were as follows. What does indoor heat even look like in a place like Miami? How do households grapple with indoor heat and energy affordability? Again, giving them equal weight. And which causal pathways lead some households to have these problems? So focusing on the first question, if you go to public meetings in Miami, you will often hear this null hypothesis, which is that indoor heat is not an issue, and that's because everyone has AC. And indeed, if you look at the data, AC saturation is super high in Miami. But the problem with that, as many people have said previously, is that this is based on an assumption that everyone has a functioning AC, that AC adequately cools their home when it's run, and that they can afford to run it. And the other problem with it is that this is really based on research from places that look nothing like Miami. Again, Miami is a very unique place in terms of its climatological, developmental, cultural context. And so this research likely doesn't transfer over. And so what we did was we wanted to say, okay, what happens when we get people who say they have this problem? People who say, I'm too hot at home. I have a bill that is unaffordable. And so what we did was we recruited people who said they had that issue. So you can see the flyers made for us by Catalyst Miami in our main languages of Spanish, English, and Haitian Creole. And we went across the county and we recruited 57 households. So what you see are census block groups colored red if they had at least one household. And the goal of this study was to try to be explorative. We were trying to understand what is the diversity of this issue as it presents itself. We were not trying to get a representative sample. And so what we then did was once people said they had an issue, they were experiencing one of these issues, we then tried to get people from diverse economic backgrounds, diverse locations, diverse housing structures. And so we collected both information about their bills, their affordability, so how much money they made. We interviewed each of the households for an hour, and we also measured indoor temperature and humidity in each of the households from June to October of 2022, and those were 10-minute measurements aggregated to an hour. And so, again, the first part of this research was to understand what does indoor heat even look like in a place like Miami. And so what I did was I recreated really wonderful work from Wright et al., who was at the time at Arizona State University, in trying to understand, what are different patterns of indoor heat. And so I took the temperature time series from those multiple months of data we had for each of our participants. I calculated all these different ways of understanding indoor heat, squashed them down using Verimax rotated principal component analysis into these 4 principal components, and ran a k-means clustering algorithm on them. And so the point there was to say, what are patterns emerging in terms of what indoor heat looks like? And so I'm going to go through some illustrative examples because I think they're very intuitive. And so what we see here from the 4 clusters we identified was an example household in each of the clusters in the first 2 weeks of August. So red was that sensor temperature measurement. Black is the airport temperature at Miami-Dade County Airport. And so you can see that some of the distinguishing factors are whether they had a diurnal or a noisy pattern. Diurnal meaning that we can see kind of the day to night fluctuations, those kind of really nice up and down curves, versus our noisy example, or coming from an engineering background, what I call the engineer's nightmare household, which seems to be uncorrelated with the outdoor temperatures. And then we also see a really big difference around the means, so where on the y-axis each of the households are. And we can see that this very hot household in the bottom right basically tracked the outdoor temperatures. So whatever temperature it was outdoors, that household was more or less inside. And taking a closer look at a couple other very heat-exposed homes, we saw one extremely concerning house, which tracked the maxes and never cooled down at night, which I think actually signals some very maladaptive behaviors. So an important role of the behavioral component. We see another pretty noisy house, so again, not at all really associated with the day to night fluctuations. And we saw a house that was very tight, which to me actually signals probably a high set point. But all of these households are kind of examples of what indoor heat looks like. And so the point of that part of the analysis was to say, okay, this is what happens if we do the best that we can with what the indoor heat research has for us. And we realized that that is only half of the equation. So the rest of this work was trying to say, okay, what happens now when we bring in the energy burden side of the equation? And so energy burden is basically the amount of money a household spends on either their electricity and gas, if they pay natural gas, over their income. So what we have here then on the x-axis is the household's average energy burden. Each dot is a household. And on the y-axis, we have their indoor heat index. So heat index also takes into account humidity. Before we just did temperature, and that was to do some comparisons between other studies who've used that methods. But here we also know that humidity is really important for the lived experience of heat, so we're including it moving forward. These are for the months of June, September, and October, which are the cooler heat season months of Miami. And what I then did was say, okay, where do they fall in quadrants? And the lines of the quadrants are what you might consider as the maximum of what is acceptable. So that horizontal line is 82 degrees, which is an upper threshold defined by the American Society of Heating and Refrigeration Engineers, ASHRAE. And the vertical line is 6%, which is often used in the energy burden literature to define affordability. So if that household is below that below the 6% line and below that 82% or 82 degrees Fahrenheit line, they're doing well. They're neither heat nor energy burdened. If they are above just the 6% line, they are energy burdened only. If they're above the 82, but not the 6%, they're heat burdened only. And of course, they can be both heat and energy burdened. And that dashed line is the average heat index. So one of the things that I want to point out is in addition to having kind of this both category, we also see very extreme heat burdens in those red and purple heat and energy burdens in those red and purple quadrants. So in addition to kind of extremes on the axes, we see the both. So both of these are kind of areas of concern for us. And so in addition to these cooler heat season months, we can also look at it for the hotter months, so July and August, and these are based off of the heat index thresholds from the National Weather Service. And again, we see our households kind of spread out around these different quadrants. And if we move, so same thing, it's just now displayed in a different way. If we look at it from our cooler months to our hotter months, we see that a bunch of those households that are doing fine when it's cooler then struggle when it's hotter. So a lot of them move from that neither category to being heat burdened, or they now deal with energy burden. And most concerningly, we see households that are struggling in the cooler months then struggle with the other issue as well when it gets hotter. And we also asked households questions about their kind of perceived impacts. And so on the y-axis, we see those same categories. So each row adds up to 100%. And so for the first question, I felt too hot at home, we see that our heat burden only group is most likely to say that they felt too hot almost every day. It's not surprising that we see a lot of our households across the board saying they're heat burdened because that was one of the things we recruited for. And then the next question, I experienced physical or mental health impacts caused or worsened by the heat in my house. Again, we see in this case, we see our both category be most likely to experience impacts, whether those are physical or mental health. I think one of the really interesting results here is we actually see our heat burning group, let me see if I can get this guy going, to be more likely to say they have mental health impacts versus our energy burden group, which is more likely to say they have physical impacts. And I actually think this is signaling of preferences. So I think what's happening here is that our heat burden only group, because they only have mental health impacts, they have a higher utility, using the terms of economics, for that extra money of having the lower bill versus the hotter home, versus our energy burden households likely are more physiologically susceptible to the heat, more susceptible to those physical impacts, and therefore preference having a cooler home. All right, I limited my AC use. We see it's most common that people limit because it's expensive if they're hot at home, whether that is the case that it's only heat or heat and energy burden. We see that households that say that they have both heat and energy burden are most likely to have an unaffordable bill. And this actually has a really interesting kind of reflection happening across the 45-degree line. And finally, this both category is also most likely to say that they forewent expenses. So there's a couple of things here I want to point out. First, this both group consistently across the board has been most likely to experience both the heat and the energy impacts, and this is exactly the group you would miss if you looked at these two issues separately, in siloed. And the other thing that I think is really interesting too with this both group is that it seems to point to a threshold that they've reached in terms of no longer getting benefit from trade-off behaviors that are well documented in the literature. All right, so the very last section of this presentation is on understanding causal pathways that lead households to having heat or energy burden. And for this part of the analysis, I use what is called fuzzy set qualitative comparative analysis. This is a quant-qual technique that works really well for medium-sized studies like this one, and it leverages set theory and Boolean algebra with really in-depth case knowledge. And so it worked really well for our case because, as I said before, there's a lot of literature independently on indoor heat and on energy, just not on them together. The nice thing is that we have microdata about energy burden in South Florida, so I was able to run some regressions on that from the American Housing Survey to try to understand significant regressors that predict energy burden. So that was another input to the analysis. And then finally, like I said before, we interviewed every single one of the households for an hour. So we had very in-depth case knowledge. And so just skipping straight to the meat and potatoes, what we found is that multiple complex and sometimes counterintuitive pathways lead a household to being heat or energy burdened. And again, the outcome here is being heat burdened or energy burdened or both, with the understanding that heat burden can mask as energy burden can mask as heat burden, and households could have the problem at the same time. And so the first group we identified were low-income female-headed households with children. This is very encouraging. This is a group that has long been understood in the poverty literature as being at risk. Next, we identified housing-constrained low-income households. And this group is really important because a lot of our people in this group were in nice neighborhoods, meaning you would miss them if you use vulnerability indices that aggregate data. And the problem here is that households actually were in good neighborhoods, good quality housing, but they could not afford it. And so they were spending all this money on the housing that they had none left over for their energy. And so that was making them run their homes at a lot hotter temperatures. And this is really in contrast to number 3, which were households with compounding physical problems. So these were households that were trying to do the right thing, trying to live in housing that they could afford, but then it was so expensive to cool that housing that they were still, out of luck. And so there's this really perverse trade-off happening between 2 and 3. And the last one were low-income senior homeowners, and I just want to flag that social isolation has come up a lot, and that was, I think, one of the big factors here for our seniors. So just to kind of close this out, I think what's really cool about this approach to understanding vulnerability and understanding what drives exposure is it's at a level that isn't hidden by spatial aggregation. And so I think one of the things I'm trying to kind of do moving forward is actually looking more in the space of energy assistance and weatherization and these more energy-focused strategies that if you kind of look up heat resilience, maybe will come up in some places, but maybe are missed because it's in a different literature. And really trying to match strategies depending on the mechanism that's driving the vulnerability in the first place. So thank you all so much. Happy to answer questions.
Thank you. That was a very impressive talk and very impressive study, and also a great example of collaboration with climate science within different disciplines. So that's great. Quick question. Yeah, go ahead. Can you come to the mic? Yeah.
Thank you. Great talk. Luis Ortiz from the Virginia Climate Center at George Mason University. I had a house that tracked the max. I had 90-degree temperatures at 6 a.m. often here in New York, like 15 blocks from here. So my question is, I'm very impressed by your sort of a measurement campaign that you ran when you placed the sensors in people's homes. In conversations I've had with colleagues, they've expressed a lot of challenges around convincing folks to, put a device in their house and coming to check it in. Can you talk a little bit about your approach to sort of, building up that trust with the community and some tips and tricks to get there for those of us who maybe want to do similar or studies that are along these lines?
Yeah, totally great question. A couple of ideas. First of all, as I kind of showed, we did this in collaboration with many organizations who already were a presence in the county in these different neighborhoods. So I think, having them circulate the material saying, hey, this is the group we trust, that I think helped us get our foot into the door. And one of the things I think that worked well was that a common approach is to kind of pay people both at the beginning and at the end. And when we were going to the houses for the first time to meet them and put the sensor, we did everything possible to make it the best experience ever for them. So we were very quick about the sensor. We told them everything ahead of time. We sent them photos. This is what the sensor is going to look like when they had questions about it, because a lot of people were like, what are you putting in my home? So I'd send them text them a photo of it. And I think one of the other things that then did was that allowed us to snowball sample. So once we then met households that were like, oh, this was super easy. You were here for 10 minutes. I got $50. You put the sensor in. It took no time at all. And do you want to go talk to my grandpa who has this similar issue? And that was really important because a lot of, especially our elderly participants who were not being reached by the modes of communication we were using, so like social media or flyers or whatever, we were able to get a lot of those populations. So the snowball sampling was huge for us. And I think that came from us really being attentive to answering their questions and being transparent upfront. And then we did the interviews at the end. And I think people, as well as collecting their bill data, which obviously we had to do after the fact, we couldn't have got that before. But I think once people had that first experience with us, which was super easy and hopefully pleasant, they were more willing, I think, to be forthcoming with us the second time we came around because they had already known, we weren't trying to scam them, which is actually a big issue in Miami, the scam culture. So yeah, I mean, it's one of those things that you just have to build up little by little.
Thanks, Lynée. We'll move on to the next question, but please, reach out to her on the coffee break. Sorry. Yeah. All right. Our next invited speaker is also from the University of Miami, Nkosi Muse, and he'll be talking about the role of land surface temperature in heat exposure. Yeah.
All right. Good afternoon, everybody. As she said, I'm Nkosi Muse. Feel free to just call me Kos. I'm a PhD candidate at the University of Miami, the Abbott Center, and also the Rosenstiel School, and I am another member of what we call our superheat trio in Miami. You just heard from Lynée, who was one member, and then we have our third, Myra, raise your hand, who is another part of our superheat trio, where we attack heat in this standpoint from using a three-pronged approach, really. Myra's more so the heat, Lynnée's good with the built environment, as you saw with that phenomenal presentation, and I'm the meteorologist. So I'm probably in the wrong section, but as Deepti talked about before, we're focusing more on local, so we are still going to hone in on some of those spatial inequities that we see across the urban heat island, especially in Miami-Dade County, using land surface temperature. And who doesn't like talking about science, right? So let's. Oh, to go to the next slide? I'm so sorry. Oh, got it. Okay, sorry. There we go. All right. So land surface temperature, right? We use land surface temperatures for multiple different things. We could use it to see how much radiation the surface is actually absorbing from solar radiation from the sun, right? We could use it to see how much it's not absorbing from the sun. We could also use it as a proxy for brightness temperature, things of that sort. And we could also use it to see how much radiation is being emitted from the surface at some point, right? And this is what's important because this radiation that comes from the surface is usually what dictates a lot of our lower atmospheric processes, especially the surface air temperature that we experience directly above the surface, right? So land surface temperature is super important because in many times it's typically well correlated with surface air temperatures. So essentially where we expect that land surface temperature is high, we'd assume that surface area temperature right above it is high, right? So imagine walking over pavement on a super hot day, asphalt, black pavement that absorbs almost 99%, really almost 100% of the radiation that touches it, as opposed to walking on grass on a very, very hot day, right? As such, land surface temperature is widely used as a proxy for surface air temperatures or heat exposure. But very few studies have looked at this in regions or looked at the relationship between land surface temperature and surface air temperature and different thermal comfort measures that experience in places that experience tropical climates. And these are regions, like Lynée kind of alluded to, she kind of spoiled it a little bit for me, but if we're talking about these regions, we're talking about areas that are seasonally muggy, right? So areas that have summer dew points above 18 degrees Celsius, which is about 65 degrees Fahrenheit, and that's a National Weather Service standard. That 65 degrees Fahrenheit with a dew point of 65 degrees Fahrenheit is considered oppressive. So imagine above that, that's a lot of moisture in the air. We're also looking at areas that are seasonally wet, so summer precipitation above 500 millimeters, which could be a lot of places, right? But then here's the last delineating factor, and that's areas that are surrounded by water. So now we're adding that geographic component that a lot of places you don't see this within many different places. And if you have to think about that, how many places is that? It's really just the Florida Peninsula, right? And in this case, we're gonna zoom in even further to Miami-Dade County, which is defined really by one large climate type, Köppen-Geiger climate type, and that's the tropical monsoon climate. But we also are dealing with this thing called climate change, right? So these climate types are shifting. So at one point, Miami-Dade was composed of a tropical rainforest climate, a tropical monsoon climate, as well as a tropical savanna climate, right? But they're also surrounded by water, which makes this issue even more compounded, in my opinion. So now, let's jump into some of the climate characteristics of this region. Air temperature in most places in the northern hemisphere is highest in July and August, right? Solar irradiance, or how much radiation is actually hitting the surface, or how much radiation is actually hitting these sensors across 7 different stations for this B plot that you see here, is highest also during the summertime. But there's a little bit of a drop off too in that June month. And that's largely correlated, or we would assume is correlated with the fact that rainfall also increases during this time. So rainfall is kind of our proxy for cloud cover, which would interfere with solar radiation hitting the surface and heating the surface, right? And that would ultimately affect our land surface temperatures. So our ultimate research question, and I'm going to jump through to 2 chapters very quickly here of my dissertation work. How does land surface temperature relate to surface air temperature in Miami-Dade's tropical climate and unique geography? And is this red button to go backwards? Okay, sorry. I'm going to jump through this because at times I see like, I don't like how I put this in order, so I'm going to go backwards. So with this land surface temperature climatology, and now this is a climatology over 10 years, 2013 to 2022 for Miami-Dade County. And you see that the mean land surface temperature across those 10 years for Miami-Dade County, the distribution of that is highest in April, May, and June, as opposed to the black dots or the black line, which is surface air temperature, and that increase is most increased in July and August. So there's a drop-off of land surface temperature in the summertime, which is when the wet season is happening, right? And that's makes us a little curious, because in most places, we'd assume that land surface temperature will also be high in July and August when that solar radiation is also most intense, right? Now, if we go back and look at this visually, and now we can ooh and ah at the maps a little bit, we see that in the A panel, which shows the land surface temperature across Miami-Dade County, we see a distinct surface urban heat island. Not just the urban heat island, but the surface urban heat island, which is representative of land surface temperature across Miami-Dade County. And it's largely correlated with the normalized difference vegetation index, which is that on the right, the greener color is representative of more greener infrastructure, and then the brown colors are more representative of the developed infrastructure that we see. And then we also have the satellite getting a little confused because we have the Everglades to the left, which are a swampy landscape, but they're also full of brushlands and not very high tree canopy structures that you may see in other areas that are surrounded by large urban canopies and forests. So jumping forward again, now if you look at this trend for land surface temperature, I know this is a noisy plot, but it tells a lot. Across 7 different weather stations across Miami-Dade County, we see the same trend where land surface temperature, which is the plot, the bar plots or the box plots, they also all increase up until about April, May, or June, where we see the peak land surface temperatures. And then the surface air temperatures, which are the diamonds that are right above, they're pretty correlated for January, February, March, and then April. But then we get to May, June, July, and August, or the wet season months, and we see that surface air temperature is higher at this time of day. So that makes it a little funky in how we use land surface temperature as a proxy for air exposure or heat exposure when we're talking about air temperature, right? Because there's almost in some places a 3-degree disparity between land surface temperature and air temperature. And if we really want to get down to the nitty-gritty of the statistics here, we can look at LST versus SAT at the same time for different seasons. So land surface temperature is strongly correlated during the winter, right? So we would assume that at 11 a.m. we could use land surface temperature to define where surface air temperature is going to be highest or quantify that relationship, right? Spring a little less, but still somewhat strong. But then we get to summer and autumn and it's just like, all right, well, we can't use land surface temperature at all. It's not going to quantify the actual heat hazard that we're looking at here. So for example, on a day where the air temperature is 90 degrees outside and land surface temperature maybe is like 75, that's not telling us much, right? And now, if we zoom out a little bit and we go to daytime land surface temperature across the entire peninsula of Florida, another region that's all considered seasonally muggy, and then also look at nighttime temperature, you see that land surface temperature in the daytime sticks out in all the different urban regions. The Orlandos, the Miami-Dade, Fort Lauderdale, West Palm Beach areas in Southeast Florida, and then also the Clearwaters, the Tamples, the Naples areas. The coastal areas and the urban areas that are standing out, right? And we see them also standing out at nighttime, but not as much in Southeast Florida. And that prompted me to think, well, what's causing that nighttime land surface temperature to be so much more elevated or warm in South Florida than it is in other regions? And that brought me to thinking about, I'm gonna jump forward again because I don't like this order. If we're talking about moisture in the air, is that the limiting factor? Is that what's stopping land surface temperature from cooling at nighttime? Because we have this increased greenhouse effect from the most prevalent natural greenhouse gas that there is, right? Now let's go back. So think of land surface temperature in an arid place, for example. We're in the middle of a desert. The surface absorbs all that radiation throughout the course of the day. We know it's pretty dry out. There's not that much water vapor in the air. All that radiation is going right back out into the atmosphere, right? But now if we add these clouds, which are representative of the water vapor, which, I mean, we also see on very warm nights too, where we have a lot of cloud cover, it feels a bit warmer, right? That radiation is being absorbed by the clouds and not only sent back down to the surface, but scattered in all directions. And we were absolutely in a seasonally muggy place last night. And if you were in the subway, then I'm pretty sure you experienced a muggy condition, right? Where that water vapor is being just thrown in all different directions, throwing all the radiation in different directions and just making it unbearable. So the research question for this chapter was, how does air moisture limit cooling of the surface in Florida's seasonally muggy climate? And I mentioned before that we were at this 18 degree Celsius threshold, but for Florida, it's 21 degrees Celsius throughout the entire course of the summer. And then you see in South Florida, it's even warmer. So we broke this peninsula down into different regions, North Florida, Central Florida, and South Florida, which all have different levels of dew point on average. And if we look at specific humidity, overlaid on top of nighttime land surface temperature, you see that the darker blue circles, which are indicative of higher levels of specific humidity, which is essentially tells us how much water vapor is in the air as opposed to dew point. It's an actual measure in grams per kilogram, the mass ratio of how much water vapor is in the air per unit of air. And we see that specific humidity is highest, not only in South Florida, but along most of the coastal regions, especially in the west coast of Florida. And if we look at that statistically, we see that average nighttime specific humidity, as it gets higher, so does land surface temperature, which would show us that, okay, maybe the surface isn't cooling as fast as it is in areas that have higher moisture. But you would assume sometimes, at least I would assume, that as you go further south, you deal with warmer temperatures anyway, right? So wouldn't you see that by default? Well, if we look at it in distance to coast and break it down this way and look at the average departure of nighttime land surface temperature across the peninsula from the mean, we see that these different stations are all stations that are closest to the coast, which have the higher specific humidity as well, also have these higher average nighttime land surface temperatures that can be 2 to 3 degrees Celsius above what the average is across peninsula weather stations. Also, North Florida had a higher specific humidity and a higher nighttime land surface temperature than Central Florida did, which was also not exactly what I expected. But then we have South Florida, which stands out so much more. They have above 18 grams per kilogram of specific humidity in the air, and then also have that nighttime land surface temperature on average of almost 25 degrees Celsius. And then if we break it down, again, even by looking closer to the coast, as well as impervious surface, we see that places that are closer to the coast have the higher nighttime land surface temperatures, but also have smaller diurnal differences in land surface temperature. So the daytime land surface temperature to nighttime, there's a smaller gap, meaning it may not be cooling as much. And then in impervious regions, of course, we assume that the more impervious surface you have, the higher the land surface temperature would be. And then the less the land surface temperature would be, and the smaller the diurnal cycle. And lastly, if we look at this compared to thermal comfort, so we knowing, and we break it down by region, the blue line is the one that I want to focus on most specifically here, because that's the South Florida. We see that there is a stronger relationship in South Florida between nighttime land surface temperature, as it's not being allowed to cool down as much, and different thermal comfort indices, whether it be the heat index, the wet bulb temperature, and then also the surface air temperature. And it's also important to note, too, that the relationship between surface air temperature and land surface temperature at nighttime in the seasonally muggy place that has this weird seasonally wet rain season that gets in the way of land surface temperature hitting the surface, the relationship is a lot stronger during the summertime. And that's probably because land surface temperature is the key factor in keeping air temperature higher at nighttime, being that solar radiation is not a factor anymore. So in conclusion, we see that land surface temperature and SAT remain positively related, but LST's explanatory power for daytime surface air temperature decreases during the wet season. And then LST and SAT are strongly related during summer nights, but it increases the power of LST's role in keeping the air warmer and also thermal comfort measures higher at nighttime, which is important because if you don't have any respite from daytime heat, and you're dealing with nighttime heat that's also elevated, that's probably going to put an additional strain on your system, right? And then also, air moisture limits not only thermal regulation of the human body, but also of the surface, right? And that maintains higher temperatures at night, potentially increasing these heat hazards. And to wrap it all up, what's going to be hopefully the wrap up of my dissertation is looking at more so of the equity and procedural justice in heat resilience and responses across these different areas that we have identified that deal with heat hazards at an increased level. So happy to answer any questions.
Great, we have time for at least one question. V? Faster? Sorry.
Maybe have someone walking around with a mic. Hi, that was a fantastic talk. Wow, thank you. I have two quick questions. So one is, have you thought about applying this kind of framework and thinking to the Caribbean and Central America to see if you see this similar kind of behavior? And then another question that my friend had up there, I'm asking for her, is why the west coast of Florida was more humid than the other parts?
Yeah, to answer the first question, I absolutely think, well, one of the reasons I wanted to look at Miami-Dade is because it would serve kind of in the United States as a case study for other places that deal with similar climates. So other Caribbean regions that are dealing with the same type of seasonally wet, seasonally muggy conditions. We would expect to see the same thing in those places, but Miami-Dade County probably has less humidity than other places in the more tropical and because technically Miami-Dade County is still subtropical, but you get closer to the equator, we're dealing with these more tropical areas, we'd probably see an even more amplified effect there. And the second question was, I'm sorry?
Humidity on the west coast of Florida.
Oh, my assumption would be that just westerly movement of air patterns is pushing a lot of that moisture from the ocean over the peninsula as opposed to being on the eastern coast. But that'd probably be a good question for some of the people from the first session too. I sometimes forget I'm a meteorologist at this point.
Is that because probably the Gulf of Mexico is probably influencing that, right? With warmer surface temperatures.
Yeah.
Great, thank you. Thanks so much. And please catch him in the break. All right, our next speaker is going to take us back to the West Coast. And so this is Giulia Belotti. And this is about transforming protection for priority populations from extreme heat in Vancouver.
Yeah, hi everyone. Thank you so much to the great speakers we had before me for setting the stage. My name is Giulia Belotti. I recently graduated from my master's degree in resources, environment, and sustainability at the University of British Columbia. And I'm currently working with a UBC research team on projects exploring the intersection between the housing crisis, health, and extreme temperature. So today I will be sharing some of the findings from one of our major projects, transforming protection for priority populations from extreme temperature, an intersectoral and community-based participatory research approach. So before getting started, I just wanted to acknowledge that our research took place on the traditional, ancestral, and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations, as well as the Katzie, Coquitlam, Kwantlen, and Tsawwassen First Nations. And I will be talking about where this region is located. And so today I will be giving a brief introduction to our project, and then I will dive into some of our main findings. I will focus specifically on barriers and experiences of cooling centers shared by our housed service users. And then I will discuss some of the proposed solutions beyond cooling centers that have been identified. And finally, I will conclude by explaining how our findings fit into a broader right to cool framework and what that is and what it means for policymaking. So this project focused, again, on the Metro Vancouver region of British Columbia in Canada, as you can see there on the map. So yes, we are back to the West Coast. And like many other parts of the world, we know that this region is experiencing more intense, frequent, and prolonged heat. And during the 2021 heat dome alone, 619 people lost their lives in British Columbia. We also know that there are resources available to combat heat and to tackle extreme heat, but they are extremely underutilized. And previous studies have indicated, as we've heard already today, that seniors and other marginalized groups are disproportionately affected by extreme temperature. This is definitely not new. And in this context, many right-to-cool initiatives are emerging. So, among these initiatives, cooling centers are one of the most popular solutions in Metro Vancouver, which is why this research project focuses on them specifically. Now, as a research team, we do acknowledge that the ultimate goal is, of course, for people to feel comfortable and safe in their own homes, but at the same time, we recognize that cooling centers serve as an urgent temporary fix that we need to think about because people are dying now. So with this in mind, with all of this premise in mind, our project had two main objectives. First, we aimed to improve access to and usage of existing services and resources, particularly cooling centers. But it also became very clear from the beginning, based on our discussions with community partners, that our project really needed to go beyond this, seeking creative and transformative alternatives to protect those at higher risks from extreme temperatures. So think about this as we really started with focusing on cooling centers, but very soon this project became much more. So to achieve these objectives, what did we do? We adopted a community-based participatory research approach. This means that we partnered with community groups from the very outset of the project, even before securing funding to this project. And these community groups that you can see here, and we do acknowledge as active partners in our research, they were really actively involved in refining the research questions, refining the interview questions we were asking, but they were also involved in the data analysis project through some community peer reviews. And at the end, we also organized a community, this knowledge exchange event, where we basically brought together some of our participants and local health authorities and decision makers to really discuss some of our findings and propose solutions and see where we can go from here. We conducted, throughout this project, we conducted both interviews and focus groups with both service users of cooling centers, and these include people who used the cooling centers, but also people who could have used cooling centers but decided not to. And also we spoke with service providers. Mostly these are people who were staff members at these cooling center locations. Our service users presented various levels of vulnerability. Most of them were seniors, most of them were tenants, and some of them lived in social and subsidized housing, and some of them were unhoused people in Vancouver. And we conducted interviews and focus groups in various languages to ensure broad representation of the demographics in Vancouver. So moving on to our findings, and again, for the sake of time, just a reminder, I will be only focusing on our findings when it comes to service users and when it comes to housed service users, mostly again, tenants. I will be focusing on their experiences. We found that our participants faced various barriers to accessing cooling centers, and we decided to divide and categorize these barriers into concerns and perceptions, operational details, and infrastructure. Starting with concerns and perceptions, we found that many of our participants shared that they had concerns about safety and hygiene around these cooling centers and these places. So for instance, you can read here, someone shared with us, personally, I have experienced situation where I took one look at these centers and immediately I just turned away. Someone else told us they put me between two people who are coughing like crazy and not wearing masks. So definitely some safety concerns and concerns of getting sick there as well. And also, very interestingly, many associated this extreme temperature centers with unhoused individuals only. So we found a lot of stigma around unhoused people. So someone told us, these community centers are not for me. They're just for people on the street. They're for homeless people. They're not very safe. This is something we heard a lot. And finally, existing perceptions of government also mattered. And I've heard this in a previous presentation, meaning that existing distrust in government institutions sometimes discouraged people from going to these places and to these centers. Now, moving on to operational details, so these also came up often. Many thought that there was a lack of specific information about the purpose and the location of these places. And also language barriers were another point raised very often. So for instance, someone told us, if you cannot speak English, you basically cannot get into those centers. Like the language spoken there is all English. Many also told us that there was a lack of activities and socializing opportunities. And this person here in particular even talked about lack of seating. She shared with us that she had to go to the washrooms to actually find seatings because these places were not really organized and equipped for a lot of seniors at one go. This was one of our senior participants. Last but not least, and again, we heard this, hours of operation as an obstacle came up a lot, especially because evenings and nights were the time where our participants told us that they suffered the most. But cooling centers were closed at this time. Many of them, at least, were closed at this time. So when they needed them the most, they were not operational. Last but not least, when it comes to infrastructural barriers, transportation and mobility issues were really prominent. One person here emphasized the unpredictability of buses, but also the challenge of waiting for a bus when outside it's extremely hot, and also the fact that inside buses or the SkyTrain, which is our metro system in Vancouver, sometimes it's just very hot. It's just very uncomfortable to be there. And many felt that there were not enough facilities around them. This is maybe connected and linked to the lack of information about where these services were, but definitely something important to keep in mind and take into consideration. So, given all these challenges, many of our participants simply chose not to use cooling centers. So what did they do instead? Instead, they used existing public and private spaces that just felt more familiar with them, even if it meant going to the grocery stores. Someone told us, we just do our groceries and we take longer to do that because then we're cool. And very importantly, many still preferred their homes, even when clearly insufficient. So they tried to sort of adopt these do-it-yourself solutions where they just took cold showers or they had ice packs ready for them in the freezer. So if these familiar places are not convenient to access, many would rather suffer at home. But what this meant is that many were dealing with very poor environmental quality. And a prominent issue is that many tenants in Vancouver do not really have control over their indoor environments, and they completely depend on decisions made by their building managers or their landlords, which is definitely a problem. And this sentence here that I'm going to show you highlights this very well. This is a tenant who shared with us, my neighbor had an argument with our building manager about this. They said there's no solution. The manager said, if you don't like it, you can leave. Find another place to live. So here we can start seeing a lot about the intersection between the housing crisis and the climate crisis, which is a very hot topic in Vancouver. So here are some potential we're moving on to policy solutions, and here are some potential improvements that, according to our participants, could be adopted to increase access to cooling centers. I won't be focusing too much on this because, as you can see, it's mostly improvements to address the points that I've already made. So, make transit cool, organize more transit. But interestingly enough, what I want to point out is that no real suggestions emerged when it comes to tackling this perceptions and concerns, so these specific issues. But other than improvements to cooling centers themselves, people really talked a lot some other solutions, which focused mostly on reallocating resources so that people can be cool and comfortable where they live. And among these, an important example that often came up is utilizing common cooling rooms in buildings. And another prominent consideration was really about advancing tenant protections in meaningful ways. And this is something I've already touched upon. For context, know that this is extremely relevant for Vancouver and Metro Vancouver, because first of all, landlords can refuse an air conditioner to their tenants, but also we're facing a very serious housing crisis there. We're called the eviction capital of Canada, meaning that a lot of people get evicted for no reason. So people are absolutely terrified of losing their homes. They would rather not ask for air conditioning. They're just too scared. So where does all of this take us? So all of this leads us to some main tensions and trends that we identified in the data and in our findings. The first one is a clear tension between individual and collective solutions on the other side. So we found that clearly many participants wanted bigger structural changes in how we tackle extreme heat as a society, but we also found that people found this do-it-yourself solutions like ice packs and cold showers as ways to almost assert sovereignty over their own bodies and over their own spaces. So definitely a tension there. Another tension we found is a tension between government-led versus community network solutions. In this case, people definitely thought that the government should do more, but remember I was mentioning this sort of distrust in the government, so there was also a preference for responding to heat through these community networks and interacting with cooler communal and community spaces in one's environment. And finally, I cannot stress this enough, there was definitely a crucial theme was definitely the intersection between the climate housing and the housing crisis. Again, in Vancouver, housing costs are skyrocketing. Landlords can refuse AC to tenants. Tenants are terrified of being evicted. And so tenants often find themselves dealing with very poor environmental quality, but still choosing to stay home. Because again, it's worse to get evicted because you could get displaced at that point. So definitely the intersection between the two crises. And this is my last slide. So this leads us to a very important point. And this is not a conclusion, this is a next step, as you can see there. This is what we're currently talking about with health authorities and local decision makers. And it's the fact basically that we started from cooling centers in this project, but actually we cannot think about this as, being tackled by one silver bullet solution. We need to think really about different solutions that address both technological innovation, improve health and well-being, but also improve housing quality and security. And it's only at the intersection between the three of these that we can really have a right to cool framework. And this is exactly where policymakers should be focusing on. And this is what we're really talking about with our community groups and again, health authorities. So yeah, just wanted to thank you everyone and then also acknowledging the UBC project team, the PI of this research, Dr. Liv Eon, and then the whole UBC project team and our community partners. Yeah, so happy to hear your questions.
Thank you, Giulia. We have time for one quick question. Yeah. So I'll just repeat the question because people online cannot hear it. So if I were to frame that correctly, frame that short in a concise way, is how do you get landlords to participate in helping address the housing issues that have been brought up?
Yeah, thank you so much for this question. This is really a great question, and this is still object of ongoing discussions. We are talking in BC specifically about regulations. Currently in the work, there's really this improvement and advancement of tenant protections that I was talking about. So this is definitely changing. For instance, it happened very recently, I think last week or a couple of weeks ago, that in Metro, like in Vancouver, now, or actually in BC, I do believe that now landlords have to fill out a very specific form when it comes to the reasons why they want to evict tenants. Now, I believe that this is only actually for in case landlords want to move back into their own house, but we're talking about, currently there's been policy conversations about making this happen also for AC. So for instance, if you want to evict someone, you have to explain that and submit a request, and that could potentially disincentivize landlords from evicting people, but it is definitely an ongoing conversation. A solution hasn't been found, and I think that there would be so much to talk about when it comes to advancing tenants' rights, and also when it comes to housing. And I think that it's really part of that broad spectrum of solutions that I was talking about. But yeah, that's a great question, and not the best answer because it hasn't been really solved yet. But there's been talks about it.
Thanks for the question. And okay, we'll move on to the next talk, but yeah, continue the conversation later in the breakout sessions too. So we have 2 more talks in this session. The next one is actually, again, also from the UBC team about using oral histories for heat justice.
Cool, yeah. Hi, everyone. Thank you so much for being here, and thank you to the other presenters as well so far for their wonderful presentations. My name is Rachel Stern. I'm also with the UBC team that Giulia is working with, but there's a few projects going on around heat right now at UBC, so I'll be talking about a slightly different one, but a lot of the same themes. So I want to start by saying I'm grateful to be with you today here in New York, also known as Lenape-Hoking, the ancestral homeland of the Lenape. And I actually grew up about 80 blocks north of here in Inwood. So I grew up in an urban environment that looks a lot like this. So living through summers here actually really shaped my own interest in the relationship between housing, urban environments, and heat. And so I'm currently a PhD student now in the Department of Geography at UBC. And so I'm looking at stories of senior tenants living through extreme heat. And this work was done where I currently live and work in Vancouver on the ancestral, unceded, and traditional lands of the Coast Salish peoples, including the territories of the Musqueam, Squamish, Stolo, and Tsleil-Waututh nations. So I think a lot of this has already been covered, which is great, but in 2021, Vancouver and the Pacific Northwest more broadly experienced an unprecedented heat dome. So the 2021 heat dome was the deadliest weather event in modern Canadian history. And as temperatures rose into the high 30 and 40 degrees Celsius, so up into the 90s and 100s degrees Fahrenheit, people really struggled to stay cool at home. And 619 people died across BC as a direct result of the heat. And almost every single one of the people who died, so it's 98% of people that died at home or in temporary housing. And further research, as indicated in the graph on the bottom right, shows that indoor temperatures are particularly dangerous because even as it cooled down outdoors at night, temperatures continued to rise indoors. So, as Giulia mentioned this already, but we see common themes, right, that most people who died were elderly, so 90% were over the age of 60, had underlying health conditions that made them more susceptible to heat, and died indoors, often in their homes. And most people did not have indoor cooling mechanisms, so BC particularly has very low rates of air conditioning, recently calculated at about 26% for older adults living alone with underlying health concerns, and it has an overall range in around 30%, so much lower than a lot of other parts of Canada. And many also lived in neighborhoods that are low income and have weaker social infrastructure. So when we're directed to the indoors and the home, we must then ask questions about the housing context. So as Giulia said, Vancouver is widely known to be in a housing crisis. So about 55% of people rent their homes. And you can see at the graph on the bottom, average rents have just been rising with a specific peak in the last few years, especially since 2021. And it is a landscape where renters by nature are insecure. As Giulia said as well, Vancouver is the evictions capital of Canada. 11% of renters reported being evicted between 2016 and 2021, and no-fault evictions, so evictions outside of the tenant's control, make up actually 85% of evictions in BC, and that's compared to an average of 65% of all evictions nationally. But we don't really have any data on how tenancy and that housing crisis backdrop actually played into the heat dome. So, given these overlapping contexts, my research has focused on the following questions. So first, what was the lived experience of the 2021 heat dome for elderly and vulnerable tenants? How has the 2021 heat dome entered individual and collective memory? And how do these experiences shape or constrain the possibilities for responding to extreme heat? So these questions really mean looking at the smaller scale of individual bodily experiences in people's homes, so centering these experiences within the context of people's lives. So in my work, I've been attempting to answer these questions through using qualitative and narrative methods such as oral histories and focus groups. So the goal is to understand the complexities of housing and heat, so using qualitative data to supplement and fill in the measures of experience that quantitative data may miss in its bigger scales. So specifically, I'm drawing on recent work that calls for better attention to be paid to heat as a chronic stressor, and focus on underlying causes of vulnerability, as well as work on a critical heat studies approach that seeks to understand heat's meaning beyond temperature measures. So oral history as a method is particularly well positioned as a way to understand the underlying causes of vulnerability, as well as how heat's meaning is understood for participants. Oral history is a way of narrating stories of experience, so it's long-form interviews, and they have been used as a way to produce public histories and counter-narratives to dominant narratives. It's also been used as a way to understand disasters such as hurricanes and cyclones, as well as a way to create community archives around extreme weather, COVID-19, and housing. So the recent work in Vancouver was also done in the context of a larger web of community partnerships. So with the Housing Justice in a Climate Emergency project at UBC's Center for Climate Justice, with the Tenant Resource and Advisory Center, which is an advocacy and legal services organization for tenants in BC, and also the South Vancouver Seniors Network, which is a network of seniors across South Vancouver. In order to understand the links between age, tenancy, and the heat dome, between February and May of 2023, we ran 2 focus groups and 14 oral histories with senior tenants in Marple, which is a neighborhood in South Vancouver. And you can see from the little map there that Marple has one of the hottest land surface temperatures calculated in Vancouver. Also, people tend to live in these buildings, as you can see here. I can try to use this. Oh, fancy. So this is a picture that I took of the kind of building that you see in Marple, which is sort of 3 or 4 story walk-up building that a lot of people live in. And the focus groups and oral histories were then qualitatively, thematically coded using in vivo. So these are some of the key themes that we found. So our oral histories focused on themes such as compounding extreme weather, relationships with landlords and building managers, displacement, social networks, family responsibilities, fears about climate change. In the interest of time, I'm going to focus in on this bundle of themes in bold here that emerged from the oral histories. So specifically, the idea that even micro levels of control over space and body matter in terms of heat experience. Even within individual buildings, the directionality of units, which floor in the building people live on, window types and ventilation, and individual informal and formal negotiations with landlords around installation of cooling mechanisms really changes the experience of heat across units. So one participant, Judith, not her real name, shared of her experience living in a top floor southwest facing unit, one of the hottest units geographically due to sun exposure. She said, "We knew it was coming, but we never knew what it was going to be like to live it. I remember it was just day after day of feeling there's nowhere to go. The heat really starts to concentrate and heat rises. In these suites on top of the building, it was like an inferno and it doesn't dissipate. What I realized is when I walked downstairs into the lobby, it was probably about a 10-degree difference. The people living on the north exposure on the ground floor units, they were uncomfortable, but it was not like what we were going through. This was life and death stuff up here. I started feeling very unlucky, whereas I previously felt lucky to have this. So Judith's experience was actually so bad that she had considered moving to a less hot unit in the building, but she had found that any unit open due to a tenant leaving or dying had been renovated, and now the rents had been raised and they were much more expensive. So another common theme when asked about the role that landlords should play in terms of providing indoor cooling was to comment on the inability for landlords to even do what's currently required of them under BC's Residential Tenancy Act. So another participant, Carol, spoke about lack of control and extreme heat in the context of existing repairs that have yet to be done in her apartment, specifically on her ceiling that has been leaking for 5 years and landlords have not fixed beyond giving her some tape. She said, "I like to find small things where I feel in control and not like with the weather changes and not being able to pay to fix my own roof. How can I still be in control? How can I still be independent? I have fixed the apartment to the best of my ability, and I don't complain about every little thing. If I can do it, I'll fix it myself. That's how I feel about the climate changes. It's not in my control, but anything I can do to be safe, that's the kinds of things I want to do. I'll make sure that I always have ice or ice packs in the freezer." So for seniors in our oral histories, the theme of independence was very important, especially around being able to keep themselves safe in their homes. So in Vancouver, policies that came out of the heat dome are largely aimed at climate upgrades and indoor cooling, and policies for indoor cooling is mainly aimed at homeowners. So tenants can often not make such changes as easily. One participant said, "I bought an air conditioner on Craigslist for $100, hoping and praying it would work, and I just snuck it in at night because I don't know if I'm allowed to have an air conditioner, but I would have died otherwise." Oops. And these kinds of life and death negotiations for tenants actually happened on a more public scale last summer in Vancouver with a free air conditioner program for low-income and medically vulnerable people that was run through the Provincial Energy Service, BC Hydro, and they're running it again this summer. But for tenants, it actually required landlords to sign an approval form. And there were multiple reports, as reflected here in multiple news clippings, that landlords would not sign the forms since there's nothing binding or requiring them to do that in the Residential Tenancy Act. So that hindered this particular policy program. So concluding, my main intervention for this presentation is actually a methodological one, that narrative forms of capturing heat experience, like oral histories, can point policymakers, community groups, governmental agencies, and researchers to the important small-scale politics and social relations that occur around heat. It helps us to understand heat events as occurring within the existing structures of inequality and vulnerability. And these insights are particularly important for designing policies and interventions around heat at multiple scales that will actually be able to function within the political context in which they occur. So knowing also that this is a very multidisciplinary environment, I have some ideas that I want to share about how oral histories might be able to fit into other types of heat research. So also understanding that oral histories can be dismissed as anecdotal, and that qualitative findings aren't always as easily, don't always fit as easily into claims about large regions that we might be used to in heat research. So a few ideas are that they could be a mixed methods counterpart. So there's an upcoming study where they're proposing to do quantitative indoor air quality monitoring and then also do a qualitative interview process with the participants as a way to create alternative forms of collective memory, as a way to understand how heat is felt beyond temperature, especially for older adults that might have different physiological responses to heat, focus groups as a way to create space for communal dialogue, and finally, as a way to link housing activism and activism or advocacy around extreme heat. So thank you so much. Happy to chat more. Come find me or send me an email. Thank you.
Thanks, Rachel. We have time for one quick question.
Very interesting work. I'm curious in your interviews whether there was an opportunity for people to talk about climate change and whether these events were influencing how their concerns and their understanding of the process.
Yeah, absolutely. So actually, the interviews were originally not framed around heat explicitly, but it was asking about climate justice and climate change more broadly. And one of the patterns that we saw, which I didn't share here, was that people viewed climate change as something much bigger happening outside of them and not in the context of the 2021 heat dome. So climate change, when it came up in focus groups and oral histories, especially for seniors, often ended up, we sort of would talk about like mitigation, we talk about carbon. There were a lot of questions around like how is climate change happening? But in order to get at their experiences of the 2021 heat dome, we had to sort of steer them towards housing. We had to ask them about heat more specifically. And so there were these bigger conversations around climate and time and like guilt, especially that older participants felt around like leaving the earth in the way that they were. But it was interesting because the term climate change didn't seem to like conjure the same kind of visceral experiences that asking about like when tell us about a time you were really hot in your home. So there was this really interesting tension there. And there was actually a whole lot of discussion around climate change that didn't make it into this presentation. So thank you.
Thank you, Rachel. Okay, we have one last talk in this session, and it's going to take us back to the Western U.S. And this is from Zachary Van Tol, circling back to the topic of compound hazards, and particularly focusing on homeless community.
All right, good afternoon, everyone. My name is Zach Van Tol, and I'm a candidate in the School of Sustainability at Arizona State University. And this is a little bit different of a presentation compared to what we've had thus far. This is actually a presentation on a commentary paper that was published in Environmental Health Perspectives back in January. And as a young scholar, I really think that this type of paper is really impactful and beneficial for students, but faculty, scholars all across stages of their career, because it gives you an opportunity to really look at where science is, the state of science, and publish something that is meaningful, providing your insights based on your life experiences. And so a little bit of background about some assumptions based on my own kind of background that I bring into this, sort of a framing for the paper and the arguments that I'm pushing forward are one, that heat is not a climate problem, it's a people problem. Number two is that people experiencing homelessness are on the front lines of this people problem related to heat, so they deserve the utmost attention in terms of research and actual implementation of strategies to resolve the issues that are facing us as a result of heat. And number three, if you believe those first two arguments, then housing and the climate housing nexus, which the two individuals who spoke before me kind of so eloquently brought forward, should be one of the areas that we look at most in terms of policy recommendations towards solutions. And so sort of what frames these ideas in this background is there's no problem with physical scientists. I am one myself. I'm a trained meteorologist with a degree from Virginia Tech. But I since transitioned to ASU, which is broadly transdisciplinary, interdisciplinary. And so starting to talk with social workers, starting to talk with health practitioners, epidemiologists, and really getting into, let me see if I can move this slide forward. Okay, and moving into an area like Phoenix, Arizona, Maricopa County, from an area, DC, Washington, DC, which has in itself a severe housing issue, but the Sun Belt generally thought of as a mild climate, especially in the winter conditions, the winter months, which is fairly prolonged despite kind of the 4 months we're living in now, where despite the humidity, I'm much more happy to be here than back in Phoenix, where we had temperatures of 118 this past weekend. Is sort of at the forefront of the housing crisis. We have a mass migration of people experiencing homelessness who come into cities like Phoenix, seeking respite from those frigid temperatures during the winter months. And so this is Phoenix, Arizona alone. Roughly 10,000 people are experiencing homelessness that are documented, and we know these are gross underrepresentations for some of the reasons that people before me have spoken of. We have about 300 sunny days, which again is sort of attractive to people who are trying to escape the snow and ice during the winter months. It's one of the fastest growing cities in the country. But we do have issues like 111 days where the temperature is above 100 degrees Fahrenheit, as well as roughly 45 days annually where we are not attaining air quality measures that are put forth. And something else that I should have put on here is 340 recorded heat deaths occurred in the city of Phoenix alone in the summer of 2023. And this proportionate number of those individuals were people experiencing homelessness, roughly 45%. And so I'm not going to go too much into depth about the kind of epidemiological reasons of why we should care about heat and air quality, but when reading the literature, what I really found out is, I know we're here for heat, and a lot of the work that we do is focused on heat. A lot of the publications that are out there about climate health are focused on heat. But when you think about air quality, and some people have already shown some of those pictures from New York City, the East Coast last year, some of the wildfires, things that are going on the West Coast, these two events kind of happen concurrently, and that is temporally, right? So you can have wildfires while the temperatures are very hot outside, but you could also have concurrently in terms of a geographic region, right? So in the wintertime in Arizona, we have fine particulate matter from people burning fires. In the summertime, we have ozone and high heat. And what you actually kind of come to realize is that particulate matter, ozone, air quality impacts the same physiological responses that heat does, just on a different time scale that science actually has yet to discern. So you can think of things like heart attacks, irregular heartbeat, aggravated asthma. The same sort of systems in our body, cardiovascular and respiratory, are being impacted by particulate matter. And as all of us know, what's been presented on ad nauseum so far is the same thing happens, right? We're concerned about heat cramps, exhaustion, heat stroke, respiratory difficulties, even death from heat. I think why it gets so much more attention is because of the acute nature that when we have heat waves, you see the headlines of hundreds of people dying. And I'm not saying that it's not deserved of the temperature, but I think we really need to start incorporating air quality and asking ourselves, is that part of the issue? And there are some publications, but I argue that there's not enough current research going on that looks at potential implications for air quality on heat-related, or in that case, air quality exacerbated heat-related illness and death. And so one way to look at this is this figure from the paper that sort of looks at these climate drivers, which I was just talking about, air quality, heat, and you have kind of two different pathways here. You have environmental determinants and social determinants of health. And these dictate what the exposure pathways are. So you can think about myself, somebody in society who happens to have housing, air-conditioned, filtered air, as opposed to somebody who's experiencing unsheltered homelessness who might not have access to these same resources. So that's their social determinants, right? The social capital an individual has, and the environmental determinants where that individual lives geographically as well as spatially within their actual city. And these all determine the exposure pathways. So again, indoor, outdoor, whether you're in an area that actually has extreme heat days or not. And all of these dictate health outcomes, which again, mortality is important, but thinking about cardiovascular risks, pulmonary diseases, kidney failures, et cetera. And sort of this overlaid Venn diagram then puts on a kind of a simplification of housing, right? And so housing quality versus the ability to secure housing are two very different things. Just because I have housing, what does that housing actually look like? What does that mean? There have been studies conducted in Maricopa, in Phoenix, that look at people who have housing, but it is mobile homes that don't have air conditioning, and they find that the inside temperatures can exceed 40 degrees Celsius easily for prolonged periods of time, and again, do not dissipate that heat at night the same way a house would that has air conditioning. So these are very important to look at in terms of a climate health lens. Bringing back sort of the homelessness perspective, right, is we have different depictions here of homelessness across our country. We know that on any given night, according to last year's report, there are about 650,000 people in the United States alone experiencing homelessness, and 6 out of every 10 of those individuals do so in an urban setting. And so we have, it's kind of no surprise here, a lot of these cities make the news, even internationally for housing issues. We have my home city of Phoenix that I currently live in, Los Angeles, Portland, and New York City. And depending on where you go and who you talk to, the types of encampments that arise, the types of individuals who are living there and their readiness to respond to the difficulties of heat and air pollution differ widely. And so with that in mind, kind of the differentiation of people's lived experiences with homelessness, I think it's really important that we think about homelessness as not just one kind of definition of status, but rather a more fluid dynamic, especially in relation to environmental exposures. And so here on the y-axis, we have high and low levels of access to mediary entitlements. Think of this as air-conditioned buses. Think of this as access to an air-conditioned home, a vehicle that you can drive into and from work. So that goes up and down in terms of level of access that you have. On the x-axis, we have environmental exposure. And sort of the solid line, I think, is what generally we depict as people experiencing homelessness, are sort of on the far right end, unsheltered homelessness. They probably have a high level of environmental exposure and very low levels of access to these entitlements, whereas somebody who's more stably housed has a high level of access and then low environmental exposure. But what we find, especially when interviewing people who are experiencing homelessness, again, as I had shown before, is that the actual ability for an individual to secure some of these mediary entitlements is not a straight line, not a linear relationship towards their housing status. So we have to really approach it as a holistic issue, thinking about the entitlements available to the person, but also the individual themselves and pre-existing conditions, social determinants of health. So that brings me broadly to sort of the future initiatives that this paper sort of points out and kind of really drives home for individuals to focus on in this space, and what my dissertation work hopes to aid in. I'm not going to be able to resolve all 5 of them, obviously, but kind of assist in starting that conversation. And so the first one, which I know we all have talked about this far, is really increasing the spatial and temporal resolution of heat stress metrics and air pollution data. And some of the ways that I've seen studies do this in a super innovative fashion is real-time technologies that are hyper-local and more of a community science-driven phenomenon. And I know that there are certain people in the scientific community who might be opposed to this option because we know that it's considered less rigorous and something that costs more money than, a $100 sensor that you can put in somebody's home. But we know that it gives us an idea. It paints the picture of what's happening, which I think is really, really important for policymakers, decision makers, which drives towards one of the main initiatives of this workshop itself, really, to bring people together from different communities to try to find answers, solutions in real time to real people's issues. Number 2 is working to understand the mental health and well-being implications of long-term exposures to heat and air pollution. And the reason that I put mental health and well-being as opposed to mortality, despite the fact that it has its own issues, and I'll get to that later in future initiatives, is I think that it's not just enough to hope that somebody doesn't die from heat and air pollution, but really pushing home the idea that everybody should be able to have a life where they can live well, have access to the mental health care that they need that's not exacerbated due to the environmental conditions in which they live. And so this is particularly amongst individuals experiencing homelessness because we know that it is such a complex issue with a multitude of intersectionality identity characteristics, The third is, again, sort of something that we've talked about before in earlier chats, is to review and improve the hospital intake methods as well as the methods to report mortality. We talk about how they're grossly underrepresented, and part of that issue is there is no nationally standardized way to account for heat mortality. And that goes beyond, obviously, the complications of being able to prove whether or not someone died from a heart attack or the heat itself, or whether the heart attack was caused by heat. But we really need to think of a way to sort of standardize it so that we can compare city A to city B, condition A to condition B. The fourth would be to construct a standardized and improved method for counting heat population deaths, as I just referred to, that actually reflect the true toll. Right? So I think a lot of times we just see a mortality number, and sure, it's kind of a little concerning, but it doesn't actually take into account potentially per capita, or thinking about maybe the economic loss for the resources that we put out there versus the talent that we're losing, the people that we're losing. So really thinking about it more holistically. And number 5 is sort of leveraging community partnerships to understand, again, the role of housing policy as it currently exists, as well as what could be done to mitigate some of the impacts of heat. And some of the initiatives, are community shelters, cooling centers, which we have a robust system in Phoenix, but I think are still kind of grappling with how do we calculate the amount of taxpayer dollars that we're putting into this, the amount of resources versus the need, the demand, the concern, and the actual results we're seeing from this, as well as more sort of robust, I would say almost controversial issues that are more involved by policymakers, like housing first, which I don't think is looked at through a climate lens, but getting an individual off the streets and into an air-conditioned house could have substantial impacts for their climate health well-being. And what I'll leave you off with is just some headlines from the news more recently. And these sound really political, but I don't think that I'm looking at them from that perspective, and I don't think most people do, though. When they read them, most people kind of jump onto the political lens. But the Supreme Court kind of overruling Boise v. Martin and what has been upheld previously as a ban on criminalizing homelessness to now opening up kind of Pandora's box as to what jurisdictions are allowed to do towards people experiencing homelessness. Phoenix police kind of violating rights of people experiencing homelessness. California implementing the care court and having kind of some haphazard results related to their attempt at ending homelessness in California. And this is all to say that heat, air quality, the work that we all do is not siloed. It really is kind of interconnected to things that are happening elsewhere in the world. And I think that it's really important that we look at it that way and try to create research that takes into account all these other kind of peripheral ideas and concepts, but also provide solutions or ideas that can easily, seamlessly fit into some of the things that are going on in the world. And so this is just a few of the ideas that I outline in the paper. The QR code there will take you to the paper, and I really appreciate everyone's time. Thank you so much.